In this video, I'm going to go over just a few more examples of solving basic derivatives. I know we did some last time, but it's really important, and you're going to be doing this kind of thing a lot. And there were 7 properties that we went over last time, so I feel like it really warrants just one more video with a few more examples. And so I'm not going to go over in depth what those properties are. So if you want to remind yourself of what those 7 properties were, just look back at my last video. I cover them there. But let's go ahead and get started with our examples. Okay, the derivative of negative x cubed minus cosine of x. How do we solve this? Well, we do like we did last time. We first start by distributing the derivative over the sum or difference. So this equals the derivative of negative x cubed minus the derivative of cosine x. And now we can tackle these one at a time. So let's look at the derivative of negative x cubed first. So derivative of negative x cubed, that is equal to the derivative of negative 1 times x cubed, right, because negative x cubed. And then we can pull the negative 1 out, and then we just have negative 1 times the derivative of x cubed. And that's just the power rule, right? That's easy to solve. So that gives us negative 1 times 3x squared, which is just negative 3x squared. The second part, the derivative of cosine x, well, that's just straight from our properties, right? That is just negative sine x. So now we put it all together, and we get the derivative of negative x cubed, which is 3x squared, minus the derivative of cosine x, so minus negative sine x. Be careful with your negatives there, be careful with your parentheses. I'm telling you, that's where people get messed up. So we simplify this and we get negative 3x squared plus sine x. This next problem asks us to find the tangent line to f of x equals x to the 4th over 4 plus 1 over the cube root of x minus 1 at x equals 1. Okay, so we've seen this kind of problem before, right? Find the tangent line. So we know that we're going to need the derivative at x equals 1, and then we're going to need our point x1 comma y1. If you're confused about how to do this, I go into this process in a lot more depth in my video on the definition of the derivative. I really break down how this works. But for this case, we're going to use our basic derivative properties to solve this problem. So let's take f prime of x. We know that we can distribute the derivative over each piece, so f prime of x equals d over dx of x to the 4th over 4 plus the derivative of 1 over the cube root of x minus the derivative of 1. So let's do this one piece at a time. The derivative of x to the 4th over 4, well, that is equal to the derivative of 1/4 times x to the 4th, which equals 1/4 times the derivative of x to the 4th, which equals, using the power rule, 1/4 times 4 times x cubed, which just ends up being x cubed. The next part, the derivative of 1 over the cube root of x, well, that's a little bit trickier because we don't have a cube root property, right? We can't just move the derivative inside the cube root. So what can we do? Well, we saw in our previous video that anytime we're taking the derivative of x that has a square root or a cube root, we know that we can make that into the power rule, right? So the cube root of x is x to the 1/3. So this equals the derivative of 1 over x to the 1/3. And we know that that is the derivative of x to the negative 1/3. And that's just the power rule, right? Don't let the fact that it's a fraction confuse you. That equals negative 1/3 times x to the 1/3 minus 1, or which is negative 4/3. And you might be able to leave it like that. There are a bunch of different ways to write this part, but I would write it as negative 1 over 3 times the cube root of x to the 4th, right? That's just negative 1 over 3 times x to the 3/4, and there are a bunch of different ways to write it. You probably could just leave it as it was, but this is how I choose to write it. And again, I know I've said this a bunch before, and I'm probably going to say it a bunch again. It's the algebra here that's tricky, right? Because you have 1 over the cube root of x, and you have to be able to know that you need to get that into the power rule, right? Because just right off the bat, you don't really know how to take the derivative of that. But you have to make it look like something that you do know how to take the derivative of, which is x to the negative 1/3. And it's the algebra, it's that step that's tricky. The calculus is just the power rule. And the good part about this, the good news is that you know algebra. So don't be afraid of it. Just use your algebra to make it look like something that you're comfortable with. And now finally the last piece, the derivative of 1, well, 1 is a constant, so it's just 0. And now we can rewrite the derivative as f prime of x equals the derivative of x to the fourth over 4, which is x cubed, plus derivative of 1 over the cube root of x, which is negative 1 over 3 times the cube root of x to the fourth, or 1 over 3 times x to the 3/4, minus 0, which is x cubed minus 1 over 3 times the cube root of x to the fourth. Okay, so that's f prime of x. That formula will give us the slope of the tangent line at any x, and we want it at x equals 1. So let's plug 1 in, and we get f prime of 1 equals 1 cubed minus 1 over 3 times the cube root of 1 to the fourth, which 1 to the fourth is just 1, cube root of 1 is 1, 3 times 1 is 3. So this equals 1 minus 1/3, which is 2/3, which is our m for the point slope formula. And again, if you are confused as to why I'm using the point slope formula, look back at my video on the definition of derivatives. And now we need our x1 comma y1, and our x1 is 1, right? And for our y1, we just plug in 1 into f of x because it shares that point with the tangent line. So y1 equals f of 1, which is 1 to the fourth over 4, plus 1 over the cube root of 1 minus 1, which is just 1/4 plus 1 minus 1, which is 1/4. And now we can write our slope of the tangent line, right? Y minus y1, 1. So y minus 1/4 equals m, 2/3, times x minus x1, which is 1. And so it looks kind of crazy, but if you were to graph out f of x and graph out this line, you would see that they touch at one point, and that is at x equals 1. Alright, well that's all I got for these basic derivative examples. Remember, if you want to see the properties listed out in more detail where I discuss them, check out my previous video. If you liked this video, or if you learned something, leave a like, subscribe, share with your friends, and I'll keep the math content coming your way.